The snap pool, this holds your snapshots, your staging disks, your mounts, and your clones. The staging disks, I often receive the question, how big are my staging disks? How many staging disks do I have? Staging disks are created from vDisks. So how many staging disks do you have? The exact same amount of vDisks that you have. As far as how big are they? Now it depends on the application type that we are going to protect. Staging disks are auto-sized at about 20% larger than the size of the application when it was discovered, with some exceptions. I'll touch on those exceptions in a moment. So if you have a Windows host, 10 gigabytes, the staging disk will be carved out at 12 gigabytes to allow for a little bit of growth. As you know, after our first full ingest, we will then go to incrementals. And that's what that 20% overhead is there for. It's to catch those incrementals or those change blocks as they come in. Now, when we outgrow that, so we've been using the same staging disk for 90 days, we've outgrown the 20% overhead. What happens? That staging disk is actually copied. We create another new staging disk using the new size of the application as the base, and then we add 20% to that. We take the data from the old staging disk, we bring it over, and then we run a full ingest snapshot to basically reset the change block tracking. We build a chain of deltas or changes off of the original image. And when this new staging disk gets called in because the application has grown, we essentially remove that delta chain, recompressing it. For some of you who are familiar with VMware, this is like a snapshot consolidation, very similar to a snapshot consolidation, in fact, where we then shorten the delta chain to make reading data from that image a lot faster. If we let that delta chain get too long, it can affect performance, especially in highly transactional databases. You will see your transactional rates slow down a bit. Now, some of the things that will fill up your snap pool more than you anticipated. So again, we'll get back to what we'll call the accidental or unknown full ingest. You have an Oracle ASM instance, you do a rebalance and you switch to the fail instance. That is going to cause a full ingest. That's a full reindex. SQL just calls it a full reindex. And that, again, as I mentioned before, we have seen that application before, we know about it, it's discovered, it's in our database. The data that lives within that application has been changed so much that we see it as a new application, and we will do a full ingest. So if you were planning on a 10 gigabyte change, and you come in and you see that you have ingested 1 terabyte, the first thing I would take a look at, if it's a database instance, is whether or not that database was re-indexed or if it has failed over. The other two items that will take up a surprising amount of your snap pool, and some folks tend to not be aware, is forgotten mounts. And I haven't forgotten about that. We will talk about how to find them and get rid of them. But this is, again, somebody in the shop made a mount to their production machine so they could work on the data. At the end of the day, they went home, they simply forgot to unmount it. We do not automatically unmount because we don't know when you're done with your data. We leave this as a completely manual process so that you determine when this data is available and when it is not. The last one is rehydration. Now, what do I mean by rehydration? If you need to restore an image that has been deduplicated, and it doesn't matter if it's in local or remote, at this point, the process is the same. Those changed blocks that are different from the copy of the data that you have in your snapshot pool. I'm going to say that one more time just to really drive the point home. We've got a snapshot image of this thing that you need to restore. However, we don't have all of it. So we're going to go into your dedupe pool, and we're going to pull the change blocks that we need to restore that image from the dedupe pool. Now, this is going to essentially build a full second copy of that image in your snap pool. So if you have a 1 terabyte Oracle instance that has been sent to the dedupe pool and you need to restore it, you should make sure that there is at least 1 terabyte of free space in the snap pool before you hit the warning threshold. And then if you're going to need to then restore it and mount it out, you're going to want room for another copy. So again, it's a 1 terabyte Oracle instance that lives in dedupe. We need to restore it, so we need 1 terabyte in the snap pool, in addition to whatever else we've got there. And then we want to mount this image out to the host so that the data can be copied back down onto the host. That's a third copy of the image for the mount. So we've got our golden copy, which is 1 terabyte. We have our rehydrated copy, which is 1 terabyte. And then we have our mounted image, which is 1 terabyte. Make sure that before you get into a rehydration where you need to mount, maybe you have something critical, you're planning something for tomorrow that absolutely has to be perfect, Look ahead into your pool, make sure that you've got the room to do this before you actually start the mount and rehydration. All right, so Snap consumers, these the big ones are going to be full ingest, which we've, I believe, talked about exhaustively at this point. Mounts, which we just covered, rehydration from dedupe or remote dedupe, which I just explained. Now, the sneaky consumers, and this is the portion where I'll get into finding old mounts and getting them cleaned up. The DB reindex, I do mention this a few times because it is generally what bites people the most. So I really want to make sure everybody takes this home. The rehydration from dedupe or remote dedupe, which I just described, that's the 1 terabyte for the main image, 1 terabyte for the restore, 1 terabyte for the mount. And the forgotten mounts. Joe, the DBA, wasn't sure what image he needed, so he mounted 12, grabbed what he needed, and forgot to unmount any of them. So there are 2 commands that you can run from the CLI. You'll see them marked here in blue. That's report mounts, and that will tell you every request to mount an image that was placed in the last 24 hours. You know, it will not give you the disposition of that mount. It will not tell you if it was still mounted, if it was taken down. It will just say a request was made to mount this data. If you want to find an image that is persisting via mount, what we want to use is report mounted images, all one word. And you'll see it there at the bottom of the slide. That will tell you every image that Sky or CDS has mounted out. And then it will also tell you the application ID that is mounted and the name of the host that you have it mounted to, which makes it very easy to locate and validate. Hey, DBA, you've got this mounted. It's on this host. Do you still need it, or can I take it down to free up some room in my Snap? Thank you for joining us for another YouTube Tech Tip video. If you like the content you're seeing on this channel, please remember to like the video, subscribe to the channel, and turn on notifications so you will be alerted to any future content.